with us. We should now be live on both Zoom and on YouTube. Continue to see people trickling in, so let's give it a couple of minutes. In the interim, Alexei, mind welcoming people?
Yeah, I see people are well prepared for the new year, for ClickHouse, as much as we do. And I'm happy to see our usual attendees. Hi, Alan. Nice to see you. Hi, Dan. Ilias Rastas. Nice to see you again. Irshad Mir. So happy that you are here. Liam Smith. Note Neymeyer. Todd. Vaidas. Nice to see you. Vitaly Kotik. How happy I am to see you in the list. So we will start in about a few minutes. And you can listen in Zoom. You can invite your friends. On our YouTube channel, we have live stream on YouTube. And you can ask questions. You can ask questions in Zoom, on YouTube, and my colleagues, Tyler and Dale, hi Dale, will help answering them. And if they will not be able to answer, I will help them.
And that happens at least once or 12 times every call, because the surface area of ClickHouse is immense. But not only that, a database is only as good as the data that's in it, and all of you store different sorts and types and shapes of data. And I think that's part of what makes ClickHouse so incredibly exciting. It's different every single day, what we get to talk about and work with.
As usual, for the best question, you will have a chance to receive a gift, a t-shirt. Not this t-shirt, this is just too exclusive. But we will find something else for you. Maybe you want a new design. Maybe you want something special, like a translation to your language. I don't know. Tyler, what do you think? What should we try?
I love it. I think there are a few things that we can try, and I'm looking forward to actually playing a bit more with Swag in the next year. It's going to be exciting what we're able to do. I think what we need to think about is at some point NASA style mission patches. I was here when this event happened. For those who've taken their time to join us. All right, Alexei. Well, we are live on Zoom and on YouTube. A couple of housekeeping items. Whichever, as Alexei mentioned, whichever channel you happen to be watching on, please feel free to use the chat. As Alexei covers what's new in this release, as you have questions, Dale and myself will be keeping an eye on them to help as much as we can and to support. In fact, there's already a mention in the hat that the swag should be a cool new beanie like the one that Dale is wearing. There's a story behind that I will let him tell you in person at some point. Amazing. So we're off to the races. Alexei, would you mind taking it away and sharing a few gifts for the beginning of the year upcoming?
Okay, let me try. So, ClickHouse release 23.12. This is a special release, a ClickHouse New Year release. And it is focused on something unusual, something that you always dreamed of, and now your dreams might come true. Maybe not, we will see. Let me present something of these features and you will tell me if it was actually your dream or something else. So we have a lot of new stuff. So let's hurry up. 21 new features, 18 performance optimizations, and 37 bug fixes. Let's start with something small but nice. Some small treats for you. For Christmas, or New Year, or Diwali, or Chinese New Year, or just for every day, because you deserve it. The first is a new syntax extension for SQL, Order By All. It is pretty easy. Just write select from somewhere Order By All. You don't have even to list the columns, and it will order by every column from the select clause. You can apply descending. You can even apply collation as usual. Just specify all instead of all your columns, because it might take a long time to list every column. Let me try this feature. It is pretty simple, but I want to show it to you, because why not? So I have ClickHouse server running on my machine. I always have ClickHouse server running on my machine, sometimes many. And let me try some queries. So here is a ClickHouse client. And if I order by all, it does nothing special, everything as expected. So it orders by price from the data set about home sales in the United Kingdom. And apparently in year 1995, there was a terraced house sold by just £1. How it is even possible? Probably it is not a house. Okay, let's try order by all desk. And as the price is the first column, it will probably find the most expensive house ever sold. So it was sold for £500 million in year 2017. And it was Unit 53, Baker Street. Okay, now let's try another query. I will just analyze my data. I will calculate median price for every year. And I will use a combination of two features. So now it is possible to write group by all and order by all. And don't bother about anything, just write it and it works. So the median price increased and increased. Let me do it slightly more interesting by using a function named bar. I will take this column and I will use a window function to calculate maximum and write and print this one. So now you can see that the price was not always increasing. It was decreasing in 2008, 2009, 2011, and hopefully in the previous year as well. But the data set has to be updated. Okay, so what else? Another feature named paste join. So how many kinds of join do you remember? Tyler, could you please start? What types of join do you know?
Inner and outer, both, and then you have to include the left version of that. That's what pops to mind first thing as I'm tweeting about it on where of course there's cross join, right? Self join. I don't know. There's probably more that I'm forgetting right now.
Okay, just
As
maybe,
of, I'm seeing in the chat.
uh, yeah, the most unusual type of join. I don't know, any ideas? Dale, maybe you?
I think our ASOF join is a good suggestion. That's pretty.
Yeah, as of join.
And maybe anti-join as well. I don't see that used very often, but we do support it. We support left and right anti-join.
Yeah, there is anti-join, semi-join. By the way, is there a thing like middle join? Middle out join? I don't know. No, it does not exist. There is also cross join, and now we also add paste join. With paste join, you don't specify any condition, and what it does, it takes one table, it takes another table, and simply paste one near another. So it will join by record numbers. And I want to run this query just to verify that it works, because I don't want to present anything that does not work. It will be pathetic. Okay, so let's try this. And we have the same data set, the same report. And what we did, we paste joined the list of numbers. We took 100 numbers, but the left table only had 28 records, so it ends at number 27. Actually, we don't, in this case, we don't have to write this paste join, because we have another nice feature already existing, named output format pretty raw numbers. So we can do this, and it will also work, and no join needed. But I hope you will find some other case when you will actually need this unusual feature. Okay, what else? Squid. Now we have squids in ClickHouse. We have a lot of strange stuff. Now also some sea animals. What it is? Short unique identifier from number. You just pass a number and it returns a string that you can use in URL to make short URLs. If a number is larger, you will get a longer string, but it is quite short. You can use multiple numbers as multiple arguments, and it will combine inside a single string. So it is pretty nice. It reminds maybe YouTube identifiers, maybe something else. And this is slightly less usual. A new function named serious period detect FFT. So FFT is a fast Fourier transform. And this function will take an array and find its main frequency. Let's come up with some demo, because it is not obvious how to apply this function. Okay, and for this demo, I will switch to my server. I have a lot of servers in my disposal, and all of them running ClickHouse. All of my servers are happy running ClickHouse. Okay, and what I will try. So I have a data set named GitHub events. All events happening on GitHub about issues, pull requests, commits, comments, whatever, in all repositories. This dataset has about 6 billion records. I will take the last 10 days, filter, group by a hour, also order by hours. And now this query is quite simple. Let's run it. It's fast. 6 billion records, 7 billion records per second, 29 gigabytes per second, and less than a second. It's just so nice, but actually I get used to it. I get used to ClickHouse, and now I want it even faster. Okay, and it looks like a periodic signal. It isn't so periodic, so it has some noise, it has some changes, but it clearly has some period. Now let's try to apply this function. So what I will do, I will wrap it inside a subquery and take everything, put it into array, and then apply this new function. Okay, 24, what is 24? We have 24 hours a day, so the answer is correct. Now let's try another example. Now I will group by minutes. What it will show? 1438. I know that typically, if you don't have daylight saving time, you have 1440 minutes every day. But this function returned 1438, almost correct. Now let's try something else. Guess what I will try next? We will group by seconds. 86,000 seconds. It works. I was expecting to get some surprise, but I did not get it. I only getting the correct answer. It is unsurprising at all. Okay, the next function. A function to calculate SHA-512/256. What is it? So we have already functions to calculate SHA-512, SHA-256, SHA-1. We even have MD5, but please don't tell anyone that we do. But if you want, actually we even have MD4, but it's a shame. Okay, now a new function, SHA-512/256. So it is a truncated version of SHA-512, but not quite. You might think that we have 64 bytes for SHA-512, and we can just truncate and get 32 bytes, like this. But if you calculate this new function, you will get another result. What is it for? It appears that SHA-512 has a subtle security issue named length extension attack. And it will be quite difficult to me to try to explain what it is, but I will try just for a challenge. So what is length extension vulnerability? Let's suppose you have a secret message that you don't know, and you have a hash of this message. And what if you can ask to concatenate a secret message with another message that you control? And given that you know the hash of the original message, you can get the hash of concatenated message predictable. It is quite a subtle vulnerability. It can be avoided quite easily. But the reason is that this full hash function exposes too much of the internal state of the algorithm. And to avoid, you just have to truncate, but not just truncate, as I showed 512 to 56 is a standard, and this standard has a slightly different implementation, and now you get this NIST approved algorithm for this function. Okay, I hope I confused you with my explanation, so let's go on. Another feature, the support for indexes on alias columns. And to explain this feature, let's suppose you have a location data. So a table with latitude and longitude, coordinates, geographical coordinates. But also let's suppose that you have a map, and a map like Google Maps, like OpenStreetMap, uses Mercator projection. And you can calculate the mapping to this projection with the following formula. I copy-pasted this formula from Wikipedia, so it is supposedly correct. Don't worry, it was Wikipedia, not ChatGPT. So it works, and you can store these columns in a table by specifying materialized. So no surprise, it is already supported. It was always working, and you can make indexes on these columns, and you can even sort the table with a mixture of these coordinates. And it will get some data locality, and these indexes will work quite efficiently. No surprise, everything works. What else? Let's suppose you don't want to store these calculated columns. Instead, you can use indexes by functional expressions. And it will work perfectly. But to use these indexes, you will have to type these functional expressions directly in your select query. Not quite convenient. Now you want to improve this by using alias columns. So you specify these columns as usual, but instead of materialized, use this alias specification. It's a column that will not be stored in a table, but calculated on the fly. And before version 23.12, this did not work. Now it works. Thanks, Vladimir, for implementing this feature, and I hope you will like it. Just in case, you don't have to use these complex indexes for location data, because we have a lot of other options. We have the support for H3. It's hierarchical hexagonal coordinate system from Uber. And we have it. You can take coordinates and apply this function geo to H3, and there are plenty of other functions. Another coordinate system named S2. It is whatever, I don't know, from Google. And I don't know why it is named S2, but again, it returns some number. And finally, we have the support for geohash. Geohash will take coordinates and return a string. And if you truncate this string, you will get some area of locations, less and less precise. You can transform vice versa to this string, to the opposite direction. You can use it as an index. So what else? What else do you need for location and geographical data? Any ideas, please write in comments, and we will be happy to implement all your wishes. Okay, another feature. A mode for alter query named apply deleted mask. Let me clarify. So we have the support for heavy deletes or batch deletes operation. You just write alter table, delete, and what you want to be deleted. For example, you want to wipe out the user named Petya. Just delete it from a table, but it will take time. It will copy all the records from the existing data parts and create a new data parts with a copy of these records, except the deleted records. There is the support for lightweight deletes. You write it even easier. Don't write alter, just write delete like this. Instead of rewriting the data and physically deleting it, it will just create a mask of records to be deleted. So it's like lazy deletion that will be applied on select and finally applied during background merges. What if you did a lightweight delete, but then suddenly decided that you want to physically delete the records? Until the latest version 23.12, you had to do optimized query that is even heavier. But now you just write alter table, apply deleted mask, and it will be faster than optimized query. So it's quite a small feature, but it is nice. Thanks, Anton, for implementing it. So, yeah, and as a bonus, you can also apply it for particular partition to optimize even further. Okay, yet another feature, a virtual column for merge tree tables named part offset. You can use it in select, you can filter by part offset, and it will just filter by a physical location of a record. I'm still wondering, if you are not ClickHouse engineer, if you don't mind about how data is physically stored inside a table, why do you need this feature? You can do pretty nice stuff with it, like you can take hundreds of records from every data part. Like in this case, we have 17 data parts, and you will get 1700 records. It works, and it works like an index. It will not read anything that it does not have to read. If you have any ideas of application of this feature, please let me know. Okay, what about performance optimizations? I like performance optimizations. ClickHouse is entirely about performance optimizations. So we have a lot of new ones. The first one is pretty simple. Count optimization for merge tables. And I have to demonstrate it. So we have a table named hits with page views. And we have 100 million records. Let me actually try it on my machine. Almost 100 million records. And it is a merge tree table, and you can see that this count query did not take a lot of time, just 3 milliseconds. And actually, I don't know why 3 milliseconds. I wanted 0 milliseconds. I don't want 3 milliseconds. I will have to take a look why it took so long. But okay, actually, we have another method to check. Let me create a merge table. What is a merge table? It can take a regular expression on table names and represent multiple tables, even dynamic set of tables in a database as a single table. So the hits merge table will access the hits table and supposedly everything else that will match this regular expression. But in this case, it will be just a single table. Let me create it. Okay, the table is already created because I have prepared for this webinar. And let me try different ClickHouse versions. So I have the previous version, 23.11. It still works. And I will try count query from this table, hits underscore merge. 85 milliseconds. It's pretty fast, 10 gigabytes a second. 26 milliseconds, 24 milliseconds. Okay. Let's compare with the latest build. Now I have the latest build. And how long this query will take? Dale, what is your best guess?
I'm going to say 0.003 seconds.
Okay. 0.025. Oh, it is slow. If it is below Dale's expectations, we have a big problem. No, actually, it was just the first invocation after the server startup. So now it takes 0.004. You said 0.003, right?
Yeah.
Let's optimize it. 0.003.
There you go.
Okay, so let's compare. The first was 85 versus 25, and the second was 26 versus 4 milliseconds. Pretty substantial improvement. Okay, we have a lot more optimizations. Memory usage for hash join. Let me try something unusual, like I will take this hits table and I will just join it by itself. And I will use the condition on URL equals to referrer. And it should work well unless you will think if you have a lot of identical URLs and referrers. And if you have like 1,000 of URLs like google.com and 1,000 of referrers, the same, google.com. This inner join will act like a cross join on this set of records, and you will get 1,000,000 of records. Then you will have another identical URL like 10,000 of records, and you will get 100 million of records as a result. And in the previous version, I tried this query, and it complained that I don't have enough memory. I thought that I bought enough memory for my workstation, but apparently it was not enough. But I don't have to hurry up and buy a new present for myself, because I can just run the next version 23.12 and the same query finishes. And it looks like it generated 51 billion of records, but the memory usage was just 8 gigabytes. So about 100 gigabytes was not enough. Now less than 10 gigabytes is absolutely perfect for this query. Thanks Leo Nen and Vladimir Cherkasov. Yet another optimizations. How many optimizations do we have? We have a lot. Faster aggregation. This optimization is quite low level, so I will use a synthetic query to demonstrate it. So take 1 billion of numbers and calculate the average for every 100,000 blocks of 100,000 numbers. In the previous version, it took about 100 milliseconds. In the new version, it takes 80 milliseconds. So it's quite a difference, but not much. Now let's look at the number of records per second. It was 9.6 billion records per second. Now it is over 11 billion, and I like it much more. Okay, another low-level optimization. Faster min and max aggregate functions. So it's about CPU dispatching different instruction sets like AVX2, AVX512, ARM Neon, and it is about batching and extra vectorization. Okay, let's take a look. First of all, I will use a single-threaded query with just calculation of maximum. And it improved more than twice. So less than 1.5 billion records per second per single CPU core. Now more than 3 billion records per second. Okay, now let's try multi-threaded query. And there is still an improvement, but slightly less, like 15%. It is still good, because now the query has bottleneck not in CPU, but in memory bandwidth. So the usage of new CPU instructions does not help a lot, but it still helps. And if you will run this query on a machine with DDR5 or HBM, you will get much more difference. Okay, now about long-awaited optimizations. I'm pretty sure you have dreamed a lot about this. Optimizations for final. So let me remind what is final, because maybe you are hardcore ClickHouse user, like seasoned ClickHouse professional. We don't have this official title yet, but probably you deserve it. but maybe you hear about ClickHouse for the first time. So final is a way to apply merging logic, data merging, on the fly on select query. ClickHouse has special table engines, named replacing merge tree, collapsing merge tree, aggregating merge tree, summing merge tree. And these table engines do some work in the background during merges. For example, replacing will get rid of duplicate records. Aggregating will do incremental aggregation on the fly. Summing, I will not tell you, you have to guess. But this logic is applied not during select, in background at unspecified point in time. And sometimes you want to get the final records like all the merging was already applied. You want it to get the logic of unique primary key, so get rid of all duplicates, get the logic of upserts, what you typically find in OLTP databases. And you can do it in one of two ways. First, explicitly specify final after a table name. Another way is to specify a setting, and this setting will have the same effect as you explicitly specified this clause. The downside, select queries will be slower. It has to be slower. It has to do more work. But how slower? And what did we do to optimize it? So the first optimization is quite easy. Don't merge data across different partitions if it is guaranteed that different partitions also have a different primary key. And you can see Maxim Kita did this optimization. Thanks, Maxim. And we have 22 times performance improvement. I would say, actually, it is infinite times performance improvement because theoretically it can work infinite times faster. The more data you have, the more will be the difference. So these numbers don't make any sense. Just remember, infinite times faster. The next optimization, it is not as simple. It looks at the set of data parts and considers the ranges of primary key covered by each of data parts. And if it appears that some of data parts have non-intersecting ranges, so they guaranteed to have different primary keys, we will not merge these data parts. I said it is complex. No, I explained it and it looks pretty obvious. So thanks, Maxim Kita, for yet another optimization to improve the speed of ClickHouse infinite times, at least 30 times. And we have even more optimizations on the way. So keep tuned. Now about something interesting, because everything else was uninteresting. Now something special. Special for the new year. What do we have? Refreshable materialized views. It's quite a big thing in the new release. It's very fresh. So ClickHouse has the support for materialized views, and it is quite powerful. You can use materialized views to create data summaries, data aggregations that will update on the fly incrementally, like continuous aggregation of your data. But this new feature is slightly different. It is about the case when you want to also create data summaries, data marts, data caches, data extractions. What else? But you want it non-incremental. You just want to calculate it from scratch every time. And how does it work? So you specify refresh, some interval with probably with offset, randomization, and you can have dependencies, and you specify a query. Okay. So what it does, it will run the select query that you specify in background and atomically replace the table with a new table. So every time the queries will run on the most fresh result of this select query. The queries will be uninterrupted. They will run without any logs. The result will just be atomically replaced. And you can configure a schedule, like run it every hour. Run it every hour, but also randomize plus minus 10 minutes to avoid overloading the system. You can even have a dependency graph. So one materialized view will update itself only after another materialized view will be updated. So you can have a chain of select queries, one querying from the result of another. Yeah, it is pretty powerful. And what can we do with this feature? For example, you can select from external database, like your old daddy's MySQL, or your old grandma MongoDB. Tyler, what is your old grandma database?
I'm going to see if I can figure out how to make this work with React, just because I think it would be hilarious.
Ah, React. Yeah, pretty nice. Okay, so you can fetch the data from external database similarly to dictionaries, but just put it into another table. You can calculate some unusual queries with aggregations, joins that don't fit into the logic of incremental materialized views. There will be nothing, no magic. They will be just calculated every time. Let me show you some demo. It will be pretty simple, but I want to validate if it will work. Let me construct something for you without any additional explanations. So the first table with counter, UN64. I will insert a number, a single number into this table. I will create a second table, also with a single column, UN64. And now the new feature, create materialized view with some name, refresh it every second, put the result to a table named counter2 as select x+1 from counter1. Oh, it doesn't work because the feature is experimental. I have to unlock it. Let me take the risk. I will unlock the experimental feature because I really want to use it. Okay, the materialized view is created, and it looks like something started to happen. Something definitely started to happen. Now I will do another thing. I will create another materialized view, also refresh it every second, but it will have a dependency on the first materialized view, and it will insert into the counter 1 table as select x plus 1 from counter 2. So now what it does, it just does something useless. It is a toy. It takes from one table, put into another, put it back like ping pong, incrementing the counter. But it works. We just tested this feature. Okay, what do we have as a bonus? The first one, it is much better to show than trying to explain. And let me show what it is. Binary map. Here it is, the binary map. And it works directly from ClickHouse server. It hosts an HTML page, and this HTML shows something like this. So you might think, if ClickHouse binary is 500 megabytes, why it is so large? I also had this question, and after I created this map, I optimized ClickHouse binary. So this map is 1 gigabyte, and the upper half is 500 megabytes. And apparently now ClickHouse binary is not so large. And every color represents a particular function in the binary. And I can zoom in. Does it look beautiful? I can zoom in and it will be refreshed, and I can click at any point and it will show that this is aggregator, a function related to aggregator. And this magenta is also aggregator, but a different function. And this is also aggregator. And this is aggregator. And this is join. Yeah, it looks nice. And now I have a question. What is this one? And I don't even know the name of this color. Something between like blue and green and light green blue. So I have two questions for you. What is the name of this color? A second question, why it is so large? And third question, what it is? I will give you just 3 seconds to answer this question, because you have a chance to win not this, a different t-shirt. Dale, do you have any hypothesis?
Well, I know the color, but we've lots of people that have answered the color.
What is this color?
The color is teal,
Uh-huh.
and that's well answered by Alon and Ramazan. But the actual reason for it, the only hypothesis, of two hypotheses. One is it's the from clause. The other is that it's static data from some external library.
Oh, pretty interesting. And if I will ask you, what do you think is closer to the truth?
I think it's going to be some sort of static file that's compiled in. That I'm going to say it's some sort of static binary that's compiled in. or it's some large file in a library. I think that's more likely, but I don't know.
Okay. By the way, the color is named, if I recall correctly, Tiffany color. But don't worry, it is just a coincidence. By the way, Tyler, what do you think? If it is a static data, what data it could be?
Yeah, unfortunately, I haven't the foggiest. I do know that if I went to that URL, I could probably find out quite quickly.
Yeah, you can find out it quite quickly, and it will be cheating, but I will appreciate cheating. So
Unfortunately, you know my challenge with browsing that particular URL on my Mac at present.
yeah, it works only for people who use Linux, not for Mac. Okay, it is named ICU DT 70 underscore dot. And it is a static data for a library named International Components for Unicode. Okay. And by the way, if you like this presentation, I invite you to check another service named reverse DNS.space. It is a map of the internet. So don't miss it. It's not a new feature, it is just a demo project. Okay, what about integrations? The biggest news is about our official Grafana plugin. Now we have version 4 in beta. It is focused on improving user experience, developer experience, lowering the learning curve, and we will appreciate your feedback in our repository Grafana/ClickHouse data source. This is the official plugin for Grafana. What else? A few improvements for MySQL compatibility. JavaScript client gets many updates, like the support for Cloudflare workers. Many updates for Power BI, Metabase, even Tableau, dbt, Beam, Kafka. Basically everything has updated. And now about the new stuff to read or to watch on holidays. The holidays are not over. You can still get some time to spend this time with ClickHouse. It is probably the best way to spend long evenings, long winter nights. Probably the most interesting is a podcast from the Geek Narrator with Tom Schreiber and Tyler. And we have a lot of new recordings on our YouTube channel, including all our webinars. So thank you for listening. Now we have 2 minutes for questions.
Yeah, we're not going to do this justice, but I've got all the questions, so we will answer some of them in the release post, because I think some will be straightforward to answer there. And there's a lot in the release, so we might go to I think we're going to make the release post bigger this month, because there's too many things there that definitely need to go in. How will the performance of apply deleted mask compared to standard alter table delete mutations, Alexei? That's probably the most important one.
It should be about the same, but slightly less expensive, because when you do alter delete, you will calculate the expression and copy all the other records. When you do lightweight deletes, it will calculate the expression first, write the mask, so the subsequent materialization of this mask will only have to apply already pre-calculated data. It still has to copy the data, but at least the calculation will be unnecessarily.
Okay, it's good to know. Some suggestions that order by star would be nice. Then we could do order by star except. That might be a nice syntactical
Good.
enhancement.
Yeah, good suggestion.
Yeah, it's a nice one. I liked it. And just on the paste join, I mean, can that be used as effectively used as a positional join? And what happens if the row counts differ between the left and the right side of the tables?
It is, in fact, the positional join, maybe a different name. And if the number of records is different, it will act like an inner paste join. So it will only join the record numbers that exist on the left and right side. So the minimum of record numbers.
Okay. Yeah, no, we've been waiting. Positional join, that's we came across, we hit a few issues recently trying to do some queries. So I'm pretty sure that's going to be very, very useful to people. Finally, just a quick one for the min-max optimizations, which the SMID optimization improvements. Is that on Graviton Apple Silicon as well, or is it exclusively to x86-64?
If I recall correctly, I hope I will not be mistaken, it applies both for x86-64 and for ARM. So on x86-64, it will choose between SSE 4.2, AVX2, and AVX512. On ARM, it will choose between ARM Neon and ARM without Neon, like this. But there are many instruction sets, so it is quite easy to get confused.
Yeah, I'm sure. There's a few questions around materialized views, but I think we can pick them up in the actual post. Just the final one, which I think is generally, can people think of this as like a cron in ClickHouse? Would you expect them to work with UDFs?
Yeah, this is a cron in ClickHouse. Actually, even better, because unlikely to the usual Unix cron, we have the support for randomization, so the spread in time to spread the workload, and dependencies and granular time intervals, so everything you need. And yes, you can use it with UDFs. You can plug in executable UDF and select from executable table function, or select executable normal function, and the function can be an arbitrary script. So it will be a quite unusual and indirect way to just do a normal cron.
Yep, I think we're going to do a dedicated post on it. I think it justifies maybe a dedicated release, an actual dedicated post on refreshable materialized views, as it's such a big feature. Okay, I think that's everything. Everything else we'll cover in the release post. Everything else was things that were good ideas to make sure that we cover. Over to you, Tyler.
I hope
amazing.
I hope we will have winners.
We do indeed. Our winners, interestingly, this time we're both in YouTube. I mentioned both of them from the ClickHouse alias on YouTube. So feel free to hit me up, Tyler at ClickHouse, and I'll make sure that we take care of that for you. I'll actually reach out to you as well. That's it. Thanks immensely for joining. We've mentioned a release post a couple of times. I dropped a link to the 23.11 release post in chat, as well as in the YouTube chat. I don't think they're as popular as they should be. They're amazing, and it is the best way to take the synthesis of sort of this content alongside some deeply written explanatory content and marry the two of them together. When you run an event like this at the end of the year, you always wonder, will folks show up? And quite a few of you did. So thank you for showing up. For those who've engaged, it means a lot. And if you are indeed celebrating holidays at this time of the year, we hope that the balance of them are amazing. If you find time, download the new release, play with it. Tell us what needs work. Tell us what's solving problems you didn't know you could solve before. And keep an eye out for the next version of this coming up at the end of January. Thank you all so much. We'll talk soon.
Thank you.
Bye.